Okay, thank you, Joe, and good evening, everybody. So my name is Dan Edmunds. I'm the founder and CEO of Espanaro Ltd. So lots of businesses across multiple sectors are very good at gathering data, and often that they don't understand how they can use this data better. I think times are moving away from data reports and graphs and moving more towards use of live data. So today we're going to investigate policy-driven decision-making to remove subjectivity and reduce the cognitive thinking time. There we go. So a little bit about Espanaro then. We are a software systems engineering house who have been working in the defence sector for a number of years. We've developed products within defence and have now moved ourselves into the security, nuclear and aerospace sectors, bringing together academics and ex-military individuals using our Espanaro military transition scheme to bring people into the business, and now moving into, like I say, other markets. So, quick overview of what we're going to cover today. I'm going to introduce the concept of policy-driven decision-making and explain why removing subjectivity is crucial for organisational success. So, what is policy-driven decision-making? This is where we use predetermined rules to make objective, consistent decisions. So, why is this important? The consistency in the decision making is a key part of data capture. Allows you to understand when decisions are correct and, more importantly, when they are incorrect. Subjectivity will bring emotion into those decisions. So, for example, in a 999 call center, if one of the call operators has just lost their nan and there's two calls coming in with an old lady and a middle-aged gentleman, there's much more likely to be an emotional attachment towards that old lady to prioritize that call, whereas obviously take the emotion out of that and they're two individuals with the same level of need. So why do we use policy-driven decision making? It's a consistent framework for decision making. So you can, like with all frameworks, it's a set once and use many mentality. So what this allows you to do is choose the framework that you're going to use, choose the decisions that you're going to make, and then make those decisions based on those predetermined rules. Utilizing technology that we have available can reduce that cognitive thinking and help reduce the burden on humans. And as we know, machines never sleep, get tired, sit in the ops room, or getting a little bit tired or stressed because there's too much stuff happening at the same time. So decisions made based off predetermined rules and live data can instantly react to situations. So that streamlined decision process, once the policy's set and the rule is in place, you can make a decision based off predetermined rules and data being fed in to almost trigger that rule. Clear accountability. I think decisions made due to the SOPs or the rules that are in place are not from the opinion of an individual. The policymaker holds overall accountability of that. So an example of this is if you've got, again, we'll go back to the police ops room. If you've got two people who are working the same shift, they're going to think very differently. If there's a decision been made, how they've determined a rule set, what they need to do is something that is subjective and increases risk. If the policy's been scrutinised, the decision will be lower risk. Also, faster reaction times to reduce risk. So being able to react faster to situations by having clear triggers to account against policies or rules that are in place will speed up the process and take away that thinking. If you imagine, again, another busy ops area where there's lots of things happening at once, being able to just stop and think is quite difficult in those times. And as we know, consistency is the key to success with all this. So that brings us on to one of the products that we've been developing within Espanaro, which is Concilium. Now, Concilium is a data fusion tool. What it can do is bring multiple data feeds into a single tool, fuse the data together and run it through a set of predetermined rules to then configure other systems. So an example of this is if we've got two sensor systems on a place of interest, if something passes sensor 1, then sensor 2, we can set a rule to set a drone in to go and investigate that area. Equally, if we are pulling in the weather system, for example, and the wind is above 60 miles an hour, you might decide not to send the drone, send in a person or send in an autonomous vehicle. Data normalization is a key feature, which is where you've got multiple disparate systems that might be recording, let's say, temperature in different one in Celsius, one in Fahrenheit. What you can do is pull that data into the system, normalize the data, and all calculations will be done in Celsius, and then there'll be a single view of that information. The autonomous system configuration, similar to what we've just discussed previously, making sure you use the data to autonomously configure other systems. Conflict detection and resolution. This is all about being able to detect when there's a conflict in the system and automatically resolving it. An example of this, if we look at a military use case, is being able to take a fob, for example. If that fob's been overrun, you could draw a box around that fob and clear all the data within that fob so that if the enemy have got in there and they've overrun there, they don't get access to the data. What you want to happen, though, is when your rescue team goes in, you don't want their radios arriving in the same place and all their data being cleared as well. And that will highlight a conflict and then be able to put a resolution in place to make sure that the rescue team can go in and not lose their communications. This system works at across three levels. So it's got the tactical, the operational, and the strategic levels. If we look at a completely different use case for this, we're going to use the HUMS data. So I forget what HUMS stands for, Health Utilities Maintenance System, I think. But yeah, the maintenance data of the vehicle that the driver of the vehicle is in. And the driver can see if there's a problem with his vehicle, can flash up on a screen to say there's a problem with your vehicle, please turn around, head back to base. That data can also be live fed to an ops room instantly to say there's a problem with that vehicle, he's going back to base. Now what we need to do from an operational point of view is bring something from QRF in to replace that vehicle. And then at the strategic level, you can see there from a mission planning point of view, and we all know no plan survives first contact. Let's say 1, 2, 3 vehicles go down. All 3 vehicles go back to base. From a strategic level, they can see that that mission is now no longer going to be complete and therefore might need to bring in some air support or further support from other areas. So that's using the live data instantly from the vehicle as it's transversed through the system. So what are the benefits of Concilium? Again, what we've kind of talked about earlier in this presentation is that autonomous decision making, being able to use the data and the preloaded rule sets or policies to be able to help make that autonomous decision without the cognitive burden. Again, next benefit, reducing the operator load. From a military use case, being in ops streams where it's absolutely hectic and there's lots of things happening, decisions are being made with a high level of stress, and lots of errors do occur in those situations. As we described with the 3-layered approach, having that enhanced situational awareness just from the tactical information coming from a vehicle all the way through operational to strategic. And like we say, it's a federated open architecture. So we're talking about certain use cases here, but this system is use case agnostic and it's data agnostic. So if you want to bring in other information into the system, that can be used to create triggers to then go and configure other systems as well. So a case study for this then is the remote monitoring of sensitive sites, recently awarded to Espanaro through DASA. We are looking at the exact use case we've discussed with the remote monitoring of sites, so being able to predict when someone is on a site and send in a drone, or as you can see there, DCE have kindly loaned us their tracked vehicle to go and investigate when drones can't fly. Some of the common challenges then that we expect to experience here is mainly around the management side of things, the resistance to change, not getting buy-in from top-level decision makers because there's autonomy involved in this is a key challenge. One of the things that we have identified is not using AI to make decisions. So the reason we use predetermined rules is because AI is a black box system. It's inconsistent and will make decisions based on whatever it decides at the time. And we've all seen it where you ask AI to do something and it will write inconsistent results every time. So there's no way of understanding where that decision's been made. And it all comes down to two key things. One being the provenance of the data that's being fed into the system, and the other being the provenance of the decisions that are being made. And that's where our rule-based system comes in. We have full access and full provenance of where those rules have come from, and they will always be accountable to the policymaker, as we mentioned earlier. Like all good technological advances, this isn't a plug and play system. So there will be a key bit of systems design, systems engineering, and full software engineering process that goes into place to understand the integration problems that will occur during this and make sure that we have a solution that fits best for the outcome of the client. Ensuring policies stay relevant. One of the other products that we bolt into this is one of our products called Pulse Sentinel. If you want to find out more about any of these products, by the way, they're on our website, espanaro.com. Please feel free to go and have a look. There's a nice AI generated video on there that is definitely not robotic. Yeah, we use machine learning and also are investigating the use of digital twins. So making sure that the information that we're pumping out of the system can be fed back in to really understand how best it can be used. Digital twins being the ability to be able to visualize what is happening within the system without actually running it on a live system to understand the impact. And I think that might be short and sweet, Joe, but that's me with a any questions slide.
Yeah, hi everyone. Todd Belden here. I'd like to thank Joe and Co for inviting me along to present about the mainly about PKI, our sort of bread and butter, and yeah, not a dry topic at all. We always open up our slides with a quote from ChatGPT, mainly because it's flavor of the month. Wow, been the flavor for quite a while, and I'll let you all have a moment to read that and think of it what you will. Right. So yeah. So as an introduction, I'm Todd Belden. I'm the founder and now the Chief Technology Officer of Unsung Limited, and that for my sins, I've been a PKI SME for over 20 years. Sort of came out of university not knowing what I wanted to do, and then sort of stumbled into a job, and they threw PKI at me, and the rest is kind of history. I started Unsung Limited at the end of 2009. If you can tell by the accent, originally from New Zealand. I did become British in 2015, but when I moved over here in 2009, I started Unsung. We've probably been working within the defence and public sector. Mainly, you can kind of tell that, I guess, from our customer slides or customer logos over on the other part of the slide, and that sort of across the board, really, Home Office, Ministry of Defence, and that there's a few others that aren't listed, and that, but I'm sure you can imagine who they are. And then, so as a company as well, we've become a member of various industry bodies. One in particular is called the PKI Consortium, which is it's like what's the nicest way I can put it, a group of vested sort of interested companies, vendors, consultancies, all sort of wanted to promote PKI and sort of do the right thing by it. And that yeah, if you get a chance as well worth looking at their website, and that they sort of release information or make information freely available for people to consume and just get them thinking about different aspects of PKI. We're also not so much a fully fledged member, but a member of the CAD forum where we're allowed to sort of participate as a vested interested party, where we can we don't have a voting right or anything like that, but we get to hear what's happening between the public CA vendors out there, so like the DigiCerts and VeriSigns of the world, along with what the big software companies are doing, or the browser vendors, so the Googles and the Apples of the world, and that forum's quite interesting, although it's for more public PKI. It's pretty interesting because a lot of the browser vendors sort of suggest sort of where the standards and that should go to, and that with the public CAs, and then they sort of debate for a while, and then more often than not, at least from our viewpoint, the bigger companies, the Googles and Apples of the world, get their way. They propose such things as like dropping TLS certificate lifetimes down to 90 days and that sort of thing. Not really thinking how that might impact customers or other people using their products, maybe internally, where there's an internal private PKI in full effect. As a little bit of what we actually offer, we sort of go across the board. We have a catchphrase of we do sort of all things PKI. So we provide consultancy services. We sort of, with our customers, aim to be that trusted partner. We can design systems, implement them, deliver them, look after them as a managed service afterwards, sort of all in everything or none of the above. And that also sort of includes getting into the weeds, where all the different components of a PKI ecosystem, we have sort of specialists in different aspects of that, all the way from like HSMs through to like YubiKeys, all that sort of stuff. Now, just for sort of a brief agenda today, I didn't want to get too far into the weeds, although it is very easy to get into the weeds of PKI. I thought I'd just cover sort of understanding at a high level, sort of the importance of PKI sort of within a business. It's not always immediately clear, and that some of the sort of challenges, I guess, of implementing PKI, a private PKI within your own organization. And then I thought I'd put a bit more of an interesting slide in there on post-quantum, just touch on a few things there, and then obviously Q&A at the end. Right. So what is PKI? So I guess in my mind, if you think of public key infrastructure, it's obviously come about through I guess the invention of public key cryptography, originally in the 60s, more publicly in the 70s with Shamir, Rivest, and Alderman, who obviously the initials make up RSA, which I'm sure you would have heard of, especially with their big conference that they have annually. But no, publicly invented in the 70s, not really used that widely. Sort of standards came through, RFCs in the 80s, and that more of a government-only area or banking-only area. But then it decided to begin in earnest, and in my opinion, wider adoption in the early 90s and stuff, as basically the internet sort of was invented and came about and has evolved. All of a sudden, PKI is sort of exploding in use, and that well, the thing I find amusing is not everyone is actually aware of how proliferant it is. And even with the internet and cloud computing, and everyone's operating off a phone with apps, it's normally a digital cert issued by a PKI, sort of pinning down and linchpinning the security of all of those sort of internet transactions and things like that. In a nutshell, I think a good PKI is made up of 3 parts, and you tend to find when engaging with customers that they'll have 2 out of 3, but not quite all 3. A really important bit, although it's the least exciting bit for at least sort of hands-on technical people is the security and certificate policies around how the governance of a PKI, what the PKI has to comply with and adhere to, and all that sort of good stuff. The obvious sort of another part of it is the technology. So I briefly sort of mentioned the PKI ecosystem. So all the different components or system components when you're building a PKI, and that from sort of hardware and software that you use to realize what a certificate authority might look like, or what an OCSP service might be doing in the background, or how am I protecting all those keys and mitigating the risk of being hacked through using hardware security modules and all of that stuff. The technology bit is probably the more interesting bit, and then the sort of third part, and possibly the most important part, is the operations bit. So without the people and procedures sort of being executed securely, then the rest doesn't really matter. They're the ones sort of I guess making sure certificates are managed properly, and none are expiring that are causing business outage or services outage. Just managed properly, and making sure those that are revoked are on a CRR, and that's distributed across your enterprise. All of that good stuff. That's still down to people, and so that's the three main elements that makes up a PKI. And like I said, normally customers have 2 out of 3 nailed. Sometimes not. Normally 2 out of 3 nailed. It's the if I compare it sort of public sector and private sector, in the private sector world, they tend to be lagging on the security and certificate policies part. So where they've definitely agreed, maybe for operation of LCAs, any sensitive tasks, it's a 2-man rule, that sort of thing. How will we identify an application or an end entity applying for a certificate? What's the identification process we'll go through? A lot of that is sort of following behind. And what you find with a lot of private sector customers is they're trying to shoehorn retrospectively the sort of decisions being made at a security level, not quite realizing that, at least with PKI, it's a bit of a cruel mistress, really. It doesn't take nicely to retrospectively fitting things in. Certain settings and values, or values that need changing. Certain settings are destructive to the point where actually you can't change that now because the horse is bolted. Your options are possibly to rebuild part of it from scratch, or come up with a bit more of a convoluted workaround. Maybe even building another CA in parallel and migrating across it. The security and cert policies part, the governance bit, definitely lacking. We see with private sector customers. On the public sector side, it's actually the other way around. The security and certificate policies governance bit is normally there and in place. It's more people skills around PKI and the technology part, and obviously the operations and running it. If there's a lack of sort of skilled people out there, they're probably not normally working for a public sector department. I mean, with a bit of luck, they could be working for us. But no, in all seriousness, that's kind of the balance of the scales between private and public, where we see differences quite a bit. And admittedly, as I'm sure probably a lot of you guys on the call realize, when you're working in public sector as well, there sometimes seems to be almost like heavy-handed, a bit too much security and governance around things for the right reasons. But sometimes it holds up actually getting things done, or getting a PKI sort of up and operational and issuing out those certs, which is essentially what you want it to do. And that the sort of 3 things, or 3 main things that PKI does enable, or once you've got digital certs out there and issued, is encryption, authentication, and the integrity of things, bits of information. And right, now, so to understand PKI, I thought I'd just go over the basics of certificate issuance. One thing I find is you speak to people about PKI and they always think, oh, it's a dark art. It's your Voldemort or something. It's really quite hard or complex or complicated. And to my mind, everything just falls back to the basic sort of steps. Certificate issuance. It's your end entity requests a certificate with a CSR, sends the identity information through to some sort of registration authority. They verify and double check that information. It can be automated, it could be manual. I'll get to that in a second. And then, once the registration authority is happy and approves your request, it gets submitted to the CA, which then in turn generates a digital cert, signs it, issues it back to the end entity for use. So I guess traditionally, sort of in starting off in the 90s, this sort of process, as simple as it was super mandrolic. It'd be someone at every step of the way doing it. So the RA would actually have a person with a set of eyes, checking X, Y, and Z, making sure that's all right before handing it over to, dare I say, a certificate authority operator who would then manually go on the CA and generate the cert and sign it and issue it out, and then another sort of mandrolic process to get that down to the end entity. That was a very sort of 90s, early 2000s approach to things, but obviously with the explosion of technology and the internet and more things automated and all sorts of cool stuff nowadays, this same sort of cert issuance process, as simple as it is, hasn't really changed. Except now with automation, you can do a lot of this a lot quicker. You can, using various protocols, your end entity, in which case in the case of a machine identity, the machine can submit a CSR with all the right information and use ACME, right, as a protocol, and it could go to logically, which looks like a registration authority, but essentially is a gateway that then takes advantage of the ACME protocol in order to verify the information in there, make sure you're from the right domain by querying DNS and doing all the right checks, and then submit it to the issuing CA or your cert authority, which in turn turns it around automatically, gets it back down to the end entity. So that this process hasn't changed in time. It's still the same old basic process, but it's just done a lot different and a lot slicker nowadays with the explosion of just modern technology and the internet and things like that. It's almost like the more things change, the more they kind of stay the same with PKI. Now, the importance of PKI in business. So these 5 pillars is what I guess PKI sort of enables or helps out from a business sense with regard to security enhancements to whatever already exists within your business. So, for instance, authentication. If you're issuing out digital certs and you're using cert-based authentication, right, it obviously helps establish trust and ensuring authorized parties can access stuff. If you're looking at setting up access to a system and you're using username and passwords, and then you bring in maybe more complex passwords, maybe even bring in pass keys, if you want a higher level of assurance, then you need a stronger version of authentication. And if that's a business enabler because you really want to make sure only your own business entities get access to information, then a digital cert for cert-based authentication is the way to go. And not just one-sided either. Mutual sort of cert-based authentication, or at least with TLS, mutual TLS, each end entity is identifying each other before they even start talking securely. There's the data integrity, so digitally signing an artifact to prove and preserve the integrity of that. If you think of what's a good example, I don't know, any sort of archives, any sort of digital archives, and that you can sign, maybe a contract, digitally sign that, used in, say, I don't know, any sort of commercial setting or legal setting, that digital version or that PDF or whatever of that contract, you can tell straight away when the signature is still, valid, even well after that certificate that signed it has expired. If it's valid for that period of time, then the document hasn't been messed with, or the integrity of the information in there is still valid. And yeah, it's been, data integrity is quite an important one, very, very much so. Encryption, and that's so not to state the glaringly obvious, but obviously PKI or public key cryptography has been around for a long time. The use of two keys is sort of a fair stroke of genius at the time, and that you can, and there are systems that we've worked on for clients where they're encrypting data with public-private key pairs. It may not be the most efficient use of, say, compute, but it does provide a level of assurance that that information is kept confidential, and that I guess one of the other uses of encryption is within key exchange mechanisms. So, for instance, with TLS, and that obviously sort of asymmetric or PKI two-key public-private key encryption isn't very good if you want quick transactions and done securely. However, within TLS, you have a key exchange mechanism where you use PKI cryptography to secure and encrypt the exchange of a symmetric key, which performs a lot quicker, but obviously can't be shared securely between two endpoints. So it's a means to an end that then allows or enables the protocol to start encrypting traffic in particular, and put that good security in place. Another favorite of mine is like non-repudiation, and that it's obviously used and achieved with the use of digital signatures and stuff. The best or one of the more familiar examples I've got of it is around secure email, where it's encrypted or digitally signed, and that non-repudiation is it's like the inability for a participating party to deny that they partook in a transaction. Kind of a weird sort of double negative to think about, but it's essentially saying is if you've digitally signed, say, an email, encrypted it, digitally signed it, sent it through, you cannot ever claim that you did not do that. It's proving that you actually did and stuff. This actually becomes sort of quite important. And then the last sort of security enhancement or the thing we find is secure communication. So PKI or digital certs, regards to protocol, sort of between two end entities, making sure that they're communicating well after authenticating and identifying each other, communicating securely, encrypted, sort of making sure that comms cannot be subjected to like a man-in-the-middle attack or anything like that. I was going to say this one, but really all five, these security enhancements then are sort of part of the building blocks to enable or take advantage of other more, I guess, popular or I don't know what the word is, famous technologies or approaches to things. Right. So if I carry on, sort of nodding to that, those five pillars, those security enhancements that PKI provides, then enables or business has business enablement through technology. So, for instance, zero trust is probably the finest or best example of it. In implementing a zero trust architecture in an enterprise, the whole point is that the end entity or the I guess the identity of that end entity is unknown to begin with. You have zero trust in it until it can prove itself. Well, with PKI, and that you can burn in, well, the vendor can burn in certificates. For argument's sake, with a device, this could be an IoT device, could be a laptop, could be a machine, can burn certificates, into the motherboard, into the chip, at its birth, at creation on the manufacturing floor plant, so that then, if you have a zero trust architecture in your enterprise and you have that entity come and join, it can prove itself before or as in the process of issuing its first, I guess, corporate or private PKI cert to identify itself, which then just builds up and it can start establishing trust in an environment where you have none. And the other sort of side to the importance of PKI in business is managing risk and compliance. So I've listed I've listed a few I guess regulation standards and stuff, GDPR or UK GDPR version of it. HIPAA in the States is a good one. That's around health information. Obviously PCI, DSS for financial transactions. And that if you're, as a business, need to meet these, comply with these regulations, if it's a case of, how are you protecting, personal data while we're encrypting it? What with? Well, we've got a PKI. It's allowing us to, enable tokenization and row level encryption on our massive data farms or database farms or anything like that. And then how are you keeping, how are you making sure that access to that information is secure? Well, we use a strong authentication, cert based, and that before anyone even has access, or before an entity or an identity on our enterprise can go off and get the right sort of tokenized credentials before they have access to that information. They need to prove themselves quite high. The data integrity again. It's like we're signing all sorts of bits of information in our repositories while it's at rest. We're encrypting it at rest. We're signing it at rest, so we know that it's it's not been messed with or ruined. And along with any good enterprise, secure comms between all the different parts and entities of your business is obviously sort of needed by most standards. And that if I realizing that this is probably the driest slide in the world on PKI, because no one's really that excited about regulation compliance or anything like that. I was just thinking of a few examples of where PKI sort of helping. One of the sort of better or more examples I can give is, I know that if you, for argument's sake, if you are a big petrochemical company, maybe a Shell or a BP, you've got oil rigs drilling out in the North Sea, for example, they've got very strict sort of compliance around maintenance of oil rigs, preventing, for health and safety reasons, for preventing, I guess, pollution into the oceans, any major explosions, that sort of thing. So they have quite a high level of maintenance that has to be carried out semi-regularly. I do know of one company that made quite extensive use of drones with 4K and 8K cameras to do the surveying part on an oil rig to see where maintenance was needed. However, that using the use of drones introduced a new threat of, well, actually, if it was a target for, I know some less than lovely people, if it was a target for maybe being bombed or an explosion set off, they used the drones and they issued the drones digital certificates and then geofencing, so that the drone would have to authenticate before it could get within a certain distance of the oil rig in order to allow it to do the maintenance survey. So not ever would I think a drone would have a certificate and be geofenced and stop within, I think it was something like 30, 40 meters. And until that authentication, that strong authentication with the certificate, was the drone allowed to approach the oil rig itself and start using those cameras to highlight where maintenance is needed. And that was like one example. I guess one of the other sort of, I guess when I first heard about it, it was slightly worried me because I tend to fly a lot. But one of the other things is on average, any plane flying internationally with a big sort of commercial airline, they have to check to make sure up to approximately 140 certificates are still valid. and working on the different components of that, A380 plane that you're going to be flying in. And if any of them, are expired or whatever else, that stops that plane from flying. And that's something I only found out about maybe 4 or 5 years ago, and semi worried me that actually, PKI is having an impact on, the compliance and regulation for commercial airlines in order to just fly a plane. There's that many certificates involved on the components that have to be valid, that can't be expired in order for that plane to take off. So yeah, as I guess the sort of point I'm trying to highlight is as this might be a quite dry sort of topic, business enablement through technology, regulation, and compliance, you can kind of see, technology with some drones is helping me stick to my, comply with the regulations, or, the making sure the checks before a plane takes off is helping me comply with aviation sort of regulations. And we'll go on to the next one. Right. So implementing PKI in your organization. So this crops up sort of quite a bit with customers. A lot of them are almost overthink the problem. I believe I still think, fundamentally PKI is sort of quite simple in its approach, kind of like the certificate issuance example. Some of the common challenges is always the standard challenges with just about any IT system or solution you're putting in. What business problem does it solve? Your upper management, your CIO, CEO, CISO, they're not really concerned about digital certificates going out and these keys do some awesome asymmetric encryption stuff. All they want to know is what does it solve for me? They're buying, because without the funding and they're buying, then you can't sort of build a solution. And then post purchasing or post having a system delivered, it's like, who's now responsible for it? And that we see that quite a lot as well. It's like, and that's kind of the same for all systems really, but no one ever seems to be wants to seem to be responsible for a PKI system. And then PKI as a whole, like it's sort of living and breathing. And then what I mean by that is digital certs, they have a start and an end date. They expire. They have a lifetime. And then when that comes to an end, you have to rotate that over. And it's almost like people who are responsible or people don't like to claim responsibility for a PKI system because of, I guess, the perceived or misperceived overhead in looking after a live system. If a certificate expires and a sysadmin somewhere has failed to renew that cert, or maybe automation broke down because of affected by a network outage or something else, services stop, business stops. You don't want to be responsible. A lot of people aren't happy being responsible for that or somewhere along the chain. And sort of some of the key steps to implementing or refreshing a PKI isn't really that different to sort of put in any sort of solution really. Sort of agreeing the use cases of what types of certificates you will support, and that a lot of nowadays a more common one is sort of supporting DevOps or enabling DevOps to be more sec DevOps, and for those developers that are only into writing code and making awesome products, making sure that they do the right thing in terms of, say, signing code, but do it in a secure fashion, do it in a way that doesn't lower the organization's security posture, because in all sort of good intentions, you might have a sort of DevOps person writing code. There was no service out there for them to easily get a certificate or get their code signed, so they've spun up their own CA and signed it themselves while they're giving it to work out a few issues, solve the issue, and then next thing you know, that's been released into the live product with a signature of a certificate that was sort of done in a bit of shadow IT. And that's just as an example. So agreeing your use cases or agreeing and identifying and knowing what they are, and possibly knowing what some future ones are. It's always a good first step. The implementing of governance, like I highlighted before, the public sector seems to be quite good at implementing governance, maybe a bit too much governance at times, but it's something you really need to nail down. The certificate policies sort of stem or are derived from your overall arching corporate security policy. It's something that isn't made too aware. And from that, in the operations side of things, we start defining roles and responsibilities. You'd write a certificate practice statement. If the policy is like what you have to adhere to, the practice statement is how you're adhering to it or how you're complying with that piece of policy. And governance makes the life a lot easier. Put in at the start. Defining the roles and responsibilities. Who's going to do what? Do we need two-man rules? The standard sort of good security practices around separation of duties, all of that good thing. It's sort of good security practice anyway, not just for PKI. And that mapping sort of compliance requirements to controls, in a sense of you have to comply with X, Y, and Z. How are you actually technically enforcing it? How are you, what are those controls to actually realize and make that a thing? And then having your operational processes and making things are done securely, in particular around making sure that the keys on your sort of CAs, issuing CAs, your OCSP servers are all secure, backed by a FIP certified HSM, all of that sort of thing. But also, and this is something we see quite a bit as well with customers, there's also the securing of those keys at all times, including with backups. And that so what we find is certain customers have built a CA hierarchy, a route, an issuing CA. They've done all the right things, the right steps, key signing ceremony, all of that good stuff, assurance, very high level for the certificates that are being issued. And then you find out, well, yeah, the backup process where we take a backup off those keys and put on a backup HSM, well, that just actually sits in a cupboard over there, not locked. Anyone have access to it, and that sort of thing. And you sort of, it's like you've got to think of the whole picture of where those keys are at any one time. If they're in an HSM, that's fine. But remember, you're taking a backup. You may even move that off-site. Operational processes to make sure those keys are secure wherever they are and whatever you're doing. And then it's rolling out the solution, and then one of the sort of main is a thing for any solution really, for any system is the ongoing monitoring across your sort of PKI ecosystem. Monitoring that your CA is up or issuing CA is up, and those APIs are available for automated certs for machine identities or whatever else. With the smart card system can knock out certs when required, and that the making sure you say your OCSP service is actually up and running and working fine is in that sort of thing, or you've issued a CRL and although it's been issued, has it had all the right publication points? Is it available? All of that sort of good monitoring across the board is as standard as with PKI as it is anything else. And that one of the things we as a company sort of pride ourselves on is choosing the right sort of PKI products and in turn coming up with the right solutions. And that there's like I sort of alluded to, there's a lot of logical components to a PKI ecosystem. There's HSMs, which is quite an important part, but there's different vendors and product flavors of HSMs. There's do I go cloud? Do I go hybrid? Do I go on-prem by cloud? At least with some of the public sector departments, that's more, I guess, an organizational private cloud as opposed to a true public one. What support is required? There's vendors we work with quite closely where their products are quite, technically quite good, but maybe their support services aren't so good. But if you come through us, we can maybe iron that out for you or help in those areas. Cert lifecycle management is sort of I'd always say like the new kid on the block in terms of PKI. It's gone to a point where obviously as technology grew, the internet grew, there's more certs going out, more certs issued. All of a sudden, you can't manage those certificates by 2 or 3 Excel spreadsheets and trying to work out who the system owner is for what part and when certs are going to expire. The cert lifecycle management products are sort of the overarching sort of operations mechanism to sort of keep a tab on, what certs are out there. Is the OCSP service up? Can I maybe reach out and get that end entity to renew its certificate automatically because for whatever reason it hasn't already, and I think it should, or all of that sort of good stuff. And also the last sort of piece of the jigsaw is it's nice having different vendor products. We stay as a company vendor agnostic, and it's nice to have, say, different vendor products, different horses, different courses, that sort of thing. But obviously then there's the sort of glue in between all of that, all the integration stuff. We'll have customers come along and say, blindly say that they need, the security vendor's, product. So, okay, but we also have a requirement for X, Y, and Z. And we're like, all right, we know that product doesn't actually integrate that well with this other product you like, but it does better with this, that sort of thing. So part of the advice and consultancy we give is when you're picking the right sort of product for the customer for their requirements, but also making sure that it's not just a system that's put in once delivered. You've got management business overhead is far too much. That doesn't help at all. So sort of us knowing what integrations work between the products so that we can then reasonably tell the customer, post delivery, to manage this, you need, A, B, C, D skills by whoever, a team of whoever that's going to take that system ownership and look after it. Right. Now the more exciting one, or the more recent sort of news-setting one and stuff, post-quantum. Right, so the quote at the top, I'm not really sure I'll read it through. So the quote at the top, with post-quantum, and I'm assuming that, most of you guys might have at least heard of like post-quantum computers. There's ongoing sort of R&D by governments and private companies to build a post-quantum computer. In a nutshell, post-quantum computers is sort of a much more powerful sort of compute platform where they can evaluate, say, 3 states of any one thing as opposed to 2 states, being a naught and one with traditional computing. There's a whole lot of nerdery behind it, and that one of the reasons a quantum computer is worrying for in the PKI space is the idea that a post-quantum computer would be able to break all of that good PKI encryption or cryptography within seconds of it turning up. So that quote that we've put up there, the Google's 53 qubit quantum computer performed a calculation in 200 seconds. They estimated it would take the world's most powerful classical supercomputer 10,000 years to compete. That is just to highlight the sort of order of magnitude of computing power that a potential quantum computer has. At the moment, in my own opinion, I think the development of a quantum computer is still very much in its infancy. So there's a lot of headlines like this all the time. It's almost like a bit of an 80s sort of arms race where, Google say, I've got a 53-bit, and then, Apple will come out and say, oh, we've got, a 68-bit and whatever else. What's sort of missing from these headlines is, sure, it could perform a calculation quite quickly. Some of the hurdles they have not yet managed to get over in the development of a post-quantum computer is around error rate. So, you might be perform that calculation. Was it very exact? No, it wasn't. What introduced errors? Well, actually, the bit of hardware or the bit of tin that we're doing, there was electrical interference, and that caused far too many errors, and that sort of thing. So I always see these sort of quotes come out about a post-quantum computer take it with a big grain of salt. Now, in order to sort of counter the threat or the perceived threat of a post-quantum computer eventually coming along and being able to break all the good PKI cryptography, NIST for the last 6 years had a competition for what they called post-quantum resistant algorithms, and that it was within the last month that they finally, yes, from a 6-year competition, they withered it down, and then they went out to draft standards, and they finally finalized those standards into version 1.0, and released them a month ago. And that I'll let you read the names and stuff. When they obviously standardized them, they had to give it a less than exciting sort of name. You know, the first one off the board, the module lattice-based key encapsulation mechanism. I talked about key encapsulation earlier, about being able to encrypt a symmetric key, securely exchange it so that then you can use that symmetric key for quicker comms, quicker encrypted comms. I mean, those Star Wars, Star Trek fans out there, formerly known as Crystal Kyber. I think Crystal Kyber would have been way cooler, probably a lot easier to remember. But no, digital signature, well, a lattice-based digital signature standard was Crystal's dilithium, but no, it's now, yeah, now that long-winded modular lattice-based digital signature standard. And then the third one, there is another digital signature standard, more on hash-based maths as opposed to lattice-based maths and stuff. The interesting thing about those digital signature ones, you might have noticed there's two. They actually have a fourth draft, which they didn't standardize this time, but apparently will be standardized close to Christmas. I think it goes by the name of Falcon or Falcons. Another nod to Star Wars there. What they found in going through, sort of coming up with algorithms that would be quantum resistant, is unlike, I guess, current cryptography, or almost legacy cryptography now, like the RSA, SHA-256, ECC, that it's not that easy to create algorithm that would be sort of a quantum computer resistant. So what they envision happening, at least with standardized, coming up with these first three algorithms on the standard, is that the future of PKI is you'll be able to build a PKI now with these post-quantum resistant algorithms, but it's going to change the way and the behavior that a PKI has traditionally worked in, because there's going to be more options on the cryptography side of things. And so they talk a lot about how a post-quantum resistant PKI will have to be crypto agile. You know, it will have to be one that can move between standardized sort of algorithms for the different signatures based off use cases, and that based off what works the best. I believe the standard that will be sort of finalized before Christmas, the Falcons one, that has a shorter key length and is much more suitable for, say, IoT devices because of their lack of compute power or power in general, and that sort of thing. So yeah, the whole going through the process of what you need in order to, say, refresh or build a new PKI, and working on those use cases with a post-quantum PKI, that still holds true, probably even more so. One of the sort of things or nice things to know in following this is that the vendors, or at least some of the main ones that we deal with, they've been supporting draft versions of these algorithms as they've come in. So their R&D, a draft version would come out. One particular company I can think of, one particular version would come out, and their R&D is on it, and they're putting it in to like their release cycle as an improvement, as an added feature, but only supported for testing purposes. Now that these have been standardized, we're expecting that the next product versions will support those algorithms fully, not just in test sort of environments, but actually into production and pre-production types of things. Yep. And so the standardization is just the start. So questions we always get is like, you know, I've heard about post-quantum. It's quite scary. It's going to break my PKI. What can I do? Do I have to build a new system straight away? All of that good stuff. And it's kind of nice to have customers being aware of it. At the moment, it really is like start planning, and planning is, it's easier said than done, but most like medium to long term planning, and so that you're prepared for when your PKI does need refreshing, and that you may need to upgrade your crypto suite to be more, I guess, have post quantum resistant algorithms are more available. And that so the first two steps and the planning, or the main two steps in the planning, is to identify those systems with data of high value and long lifetime. So like an archived sort of repository, and that you've got encrypted. You've obviously, as an organization, value that information quite highly, hence you put all the good security around it already. Well, they might be a good candidate to possibly re-sign, re-encrypt with these newer algorithms if possible. Identify system with changes are infrequently made. Components are quite long life. They've obviously been a long life product for a reason. That long life may now be shortened because of a post-quantum computer threat. It's like, right, what are we going to do with this? Normally it's a piece of hardware when we've seen it. What does it do? Can we find a newer flashy black box that provides us a good replacement? But no, it's definitely the planning. Planning is a big thing. And that my own take on the sort of post-quantum computing, and that is really, I think, I know the angle from a PKI I sense is security will break with the existing legacy algorithms. It's all going to go to custard basically. The bit I find is I actually think it's a good thing that the post-quantum research, so the research into a post-quantum resistant algorithms, has sort of forced, I guess, PKI, but not PKI entirely, but it's sort of forced, I guess, organizations or bodies around the world to actually think about the public suite of crypto algorithms and actually make improvements to them and have a reason to strengthen. And that one of the side effects of this, I guess, is if you think different suites of legacy algorithms came out a long time ago, some 30, 40 years ago. If you think, as a digital signature or a hashing algorithm, SHA family came out, and there was a SHA-1, and that was good for so long. And then eventually it was like computers got quick enough, powerful enough that SHA-1 is no longer fit for purpose and is breakable and all the rest of it. And so I guess as an industry or as a body around PKI, what did we do? We thought, right, well, we'll just still use SHA and we'll just give it a longer key. We'll go with SHA-256. So it was sort of the lazy way of solving a problem or perceived security risk, when really, that there should have been some impotence or effort put into actually, why don't we come up with stronger, better algorithms? And so the threat of a post-quantum computer has, for the last 5-6 years, got a lot of focus and a lot of money and a lot of funding in basically the brighter people on the face of the planet coming up with better cryptography algorithms that are quantum computer resistant. But at the same time, in my mind, it's probably long overdue. It's probably long overdue that we should have refreshed and replaced those algorithms that have been around for 30, 40 years, and since the dawn of the internet, they haven't really been updated for a while. So I kind of see it as a secondary benefit that's possibly more important. And that, now if I quickly go through. All right, just to conclude, touching on a few other subjects is the business enablement through technology, and that the 5 sort of security enhancements are there. The managing risk and compliance and the regulation, and sort of planning and getting ready for quantum.